Alright, in this video we will continue to practice using our trig identities to find the value of a trig function given the value of another trig function. In the previous video I introduced these Pythagorean identities, and I showed you that if you memorize this first one, sine squared theta plus cosine squared theta equals 1, you can easily use it to find the other two. So it's not so critical that you have these memorized because you can find them pretty fast. So if you did not watch the first video, you should go back and definitely watch that before you watch this one. Alright, in other words, we're about to do number 3 and 4, but we already did number 1 and 2. So if you haven't seen 1 and 2, go back and handle your business. Anyway, so number 3. Cotangent. As soon as I see cotangent, I'm looking and I'm seeing, oh look, the third one has cotangent in it. So let me give that a try. Alright, so 1 plus cotangent squared theta. Alright, 1 plus cotangent squared theta is equal to cosecant squared theta. Alright, great. So if I substitute this in, so this becomes 1 plus, alright, and cotangent theta is 5 over 6, so this will be 5 over 6 squared is equal to cosecant squared theta. Okay, now, so that's going to be 1 plus 25 over 36, okay, is equal to cosecant squared theta. Now 1 is a chameleon. If I want a denominator of 36, so these can be easily added, you can change 1 into anything you want just by putting that number over itself. So I'll just go 36 over 36 out of it, and immediately I have like denominators. So it's just a matter of 36 plus 25, which is 61. So that'll be 61 over 36 is equal to cosecant squared theta. If I take the square root of both sides, don't forget your plus or minus, then that's going to give me cosecant, alright, not squared anymore, so cosecant theta is equal to plus or minus radical 61 over 6. Alright, I took the square root of 36 to get this. Now cosecant is the reciprocal of the sine function, which is what we're looking for. So that means sine theta is going to equal plus or minus 6 over radical 61. To decide whether we're going to go with the plus or the minus, look at the quadrant that we're in. Okay, so when they say between pi and 3 pi over 2, well, here's pi, here's 3 pi over 2, so that means we are right here. And sine is definitely negative in this quadrant, so it's not the eraser. So we're going to go with negative 6 over radical 61. Okay, so that is how you do number 3. Alright, number 4. We've got cosine. So let's go ahead and use the main function, the main identity, I should say. Sine squared theta plus cosine squared theta is equal to 1. And see what we get. So this will become sine squared theta plus, and I'm putting the 2/5 in for cosine theta, so that'll be squared. So that'll be 4/25. Okay, is equal to 1. And then we would subtract 4/25 from both sides. Now 1 is the chameleon, so I can see I need 25ths, so I could replace the 1 with 25/25. Okay, so that's going to give me sine squared theta is equal to, of course, 25 minus 4 is 21, so I've got 21/25. Then we would take the square root of both sides. Don't forget your plus or minus. So at that point we have sine theta is equal to plus or minus root 21 over 5. I went ahead and did the square root of 25, and so I have 5. Now, we want cotangent. Well, we know that tangent is sine over cosine. So cotangent is going to be cosine over sine. But real quick, let's nail down the sign of the sine value here. Will it be positive or negative? Now we're supposed to be between 0 and 90. That's the first quadrant, is between 0 and 90. So everything is positive in the first quadrant, so we can get rid of the negative sign. So like I was saying, cotangent is going to be cosine over sine. Now in the very beginning we were given that the cosine is 2/5. Alright, so that's 2/5 over, and we just found that sine theta is radical 21 over 5. So how do you divide fractions? You multiply by the reciprocal. So the cotangent of theta is going to be 2/5 times 5 over radical 21. Now these 5s are going to end up canceling out. So the cotangent of theta is going to equal 2 over radical 21. Okay, I'm going to end this video on that note with number 4 there. But there are plenty more examples to come. If you would like to see more, watch the next video, and we'll just keep on doing more of these.